What if your 3D printer could do more than make plastic parts? What if it could unlock real metal casting right in your home workshop? Today, I'm putting that idea to the test with two different 3D printed casting methods. I want to see which ones actually work, which ones fail, and whether either can beat a popular traditional casting technique. The results were pretty surprising, so let's check it out. As you may know, I'm a fan of 3D printing, but sometimes a 3D print is not the right solution, and having the ability to more easily cast metal parts would be ideal. So today, we're going to see if we can make that possible. So option number one is painfully simple. We have this two-part, this is a one wall with 5% gyroid infill, 0.4 millimeter nozzle, 2 layers for the bottom, no layers for the top. They're going to be glued together just like this. So it's going to be really clean. I'm just going to use super glue for this one, but you could use hot glue as well. And we'll glue on a piece of styrofoam as well to come up so that we can actually pour into this. For the second method, I've designed a basic positive mold with walls all the way around it in Fusion, printed it on my H2C. Now it's important that this mold stays completely flat, so to minimize the chances of warpage, it is printed very light with minimal walls, minimal tops and bottoms as well, and as very light of an infill as possible. I've oversized our blank to include an allowance for shrinkage and also for machining as well. Scaling the part up will not work here. We need to offset the internals to be smaller and offset the externals to be larger. We also need to adjust the length too, so we end up with a usable part at the end after everything shrinks and after machining. So with this design, it's actually pretty cool because this is very much like what you'd see in industry, except for just 3D printed. And we have an area here for where you can see the core is going to sit. So this is the mold for the core. Nothing fancy, it's basically just a stepped cylinder on the inside there. That's going to sit inside. And then another area here that I focused on was the pouring basin. If we had a pouring basin that was curved, as we're pouring the molten metal in, it's going to want to swoop in and bring in some air into our part. We don't want that at all. So instead, we want to leave these crisp, sharp corners. It's going to create some turbulence. And we have the two parts, and there are some alignment pins there as well. And everything is made and designed so that there's a little bit of clearance where the parts need to come together. I don't want to have an issue where I've got the core that doesn't fit properly into the mold. For the mix, I'm using Plaster Paris. It should work really well for aluminum casting, and I will add some sand to act as a way to help strengthen the plaster a little bit. This Plaster Paris is made by DAP, and it has only 6 to 10 minutes of working time. So we need to be really quick and also mix it in small batches. So these have been sitting just about an hour or so and they're still warm. So I'm gonna let them set for a little bit longer. And then the next step is to remove the plastic. If I were to do this over and over again, I would have designed this differently. I would have had draft angles on here. And that way, maybe I spray a release agent and then the plaster can come right out of there. And then we can reuse the mold again. But I didn't want to spend too much time because I don't really know if this is even going to work. So while that plaster is curing a bit longer, we can get set up to melt some metal. So we're going to need something to melt the metal. Here I have an electric furnace. This one's really nice. It's relatively safe in comparison to a gas furnace. You have these graphite crucibles that go in there. You can see this one here is quite well used and they do deteriorate over time. Well, all crucibles deteriorate over time. This one's a brand new one. That's what it looks like. Fresh, nice and clean. There's a pouring spout there too. We need something to be able to grab those crucibles as well. So there's a pair of tongs there. When we are melting the metal, there's going to be a layer of oxide and a layer of scum or rubbish that accumulates on the top. We need some way of skimming that off, so we have a metal spoon here. One thing to keep in mind with these spoons is to try and keep them as warm as possible, because as soon as you dip it into the metal, it's going to want to cool that hot molten metal off. We need something to put that dross or that garbage into. So here I have a clay graphite crucible. And here is some that we can actually probably salvage and put right back in there and remelt. We need some safety equipment. I have a chemical respirator and something to protect my eyes too. I have some welding gloves. That's especially important because when we do this process, it's going to be burning out and creating a whole bunch of fumes as this burns out. We're going to need something to melt as well, and ideally it's going to be cast aluminum and not extruded aluminum. The chemical composition for cast aluminum is slightly different. And we're going to get something that looks kind of like this. These are all aluminum here. I also have some copper that I've done, although copper takes a much higher melting temperature. And when we're casting, we want to make sure we melt more than we need because we do not want to run out a little bit early. We want to make sure we have enough to fill the mold completely. Any excess can be poured into one of these or whatever you have. And then you'll get these little bars that you can put right back in and remelt again. And there's one more thing we're going to need, something that's metal to put the sand into, because no matter which way we're doing this, we need sand to go into here. It's also going to make this much safer as well. This filament dryer goes up to 100 degrees Celsius, so I thought I would start with that to soften the PLA so that I can more easily remove it. Honestly, it probably would have been a better idea just to add some draft angles. I can remove the plastic from the plaster of Paris just to save myself some time. The temperature that I found works really well for melting and pouring aluminum is 760 degrees Celsius. It's about 100 degrees higher than the melting point of aluminum. But since it's cold out today, I've set it just a little bit higher so it still flows really well. This is sodium carbonate. It's super easy to make on the stove just by cooking regular baking soda until it stops gassing off. It's going to act as a flux for our aluminum.
So you might notice that I adjusted the size here, and that's so that I can take that piece and put it back in. The other one was too big.
Okay, let's see if this one did anything. This one feels a lot better. Oh, okay. Still hot, still hot. Okay. I've been drying these total for about 6 hours or so. Some of that time was actually when it was in the PLA casing, if you want to call it that, or the mold, to create the mold. And I have some aluminum ready to go here. It's just heating back up after putting another bar in. So wait till that gets to temperature. So in your typical Lost PLA setup, you will have a plaster mold, but it's going to completely encase the PLA part. And what's going to have to happen is you need a burnout process to get rid of all that PLA in there, just like you would if it were a wax mold. So in this process though, we've done it completely differently. We have it so that you can separate it into two pieces. You get the PLA out of there, and then all you need to do is dry this. So it becomes a lot easier. You don't need another furnace. And the other benefit of a mold like this is if we can keep the mold really hot, I'm trying to get it around 200 or 150 degrees Celsius, we're going to be pouring in around 700 degrees Celsius or 725 by the time it's coming out into this mold. So it's not going to cool it down as dramatically as if we're pouring into, for example, sand, which is just at room temperature. One of the drawbacks though is that it takes quite a while to dry this out completely, and that's in part because I didn't really let it dry out naturally. So I was trying to speed up the process just by putting it in the oven for a high temperature for quite a while. One of the issues with this type of system is that there's a lot of moisture that went into creating this. We want to make sure we get as much of that out of there as possible. It's very hot, very hot.
See if it works. Wow, that's working really well. That seems to be about the right amount of material. A little bit of bubbling, it's not good, but we'll see.
Oops.
That's so cool.
Wow, that worked awesome.
Yeah, that
Doesn't that
looks so good.
Holy cow. Whew, that's a hot tamale. This is what it looks like if we were to cast directly into a metal tin. Those tins do tend to be lined with some type of plastic. So the hot molten metal goes in. Sometimes these gas bubbles can form and they can't get out. So we have these big voids, unfortunately. On the top it's quite rough, so that's not really great. And we don't have any hole in the center either. So although there's plenty of material there, it would be a lot of work to actually get the final part out of that. This one was a smaller tin, so it's sunk in quite a lot on the top. Some inclusions in there as well. And then we have this one here, same kind of idea. We have these voids in the bottom, a really rough top. So quite a bit of material to remove. Unfortunately, these are a little bit too big to put into the crucible to melt them back down. I didn't really want to cut them back up, so eventually maybe I'll get a larger furnace to be able to melt these down. So here we have the PLA version of the lost foam method, and the foam part did really well. When it came down and made contact with the plastic, I think what's happened is it's created a gas, and you can actually see here it's melted a portion of this side, maybe because of the gyroid infill. That's where the gases were able to get to really easily. And I think it couldn't really escape, so instead it blocked any more molten metal from getting in there. So I could tell when I was pouring, it didn't seem like much metal was going in. So I had a lot of hope for this one, but unfortunately it was just a complete fail. So then we have this proper lost foam, and it looks kind of awful, but I actually think that it's perfectly usable. It's oversized in all directions. You can actually even see that it captured some of the tabbing when I cut the foam on the CNC machine. I see these tabs that are remaining. So it was able to preserve quite a bit of the detail, and I think if I chose to use the XPS foam, the pink foam, which I think will have a little bit more detail than the regular white polystyrene, I think it would have produced better results too. I don't quite know what happened here, whether this was an issue with gases or I was pouring maybe too slow, but you can see here we had a little bit of trouble. And then here, there's also, I think the two are related, but I can't be 100% sure. And at the very end of this video, I will cut this off as well, and we'll have a look inside. And then we went from a PLA print to a plaster mold to our final aluminum part. And it's not like there weren't issues with this. There is definitely room for improvement. This is missing a riser, and I think it needed more vents on the top as well for gases to escape. So if we look here, we have this area that comes up for the vent, but down here on the sides, you can see it dips down where it wasn't being vented properly. So my guess is that we were having some trapped gases in here. And the likely reason for that is because this does not breathe. There's nowhere for the gases to easily escape. Overall though, really good. And if we take a measurement of this, 2 1/8 would be great. So 58.31 millimeters, and that in inches is 2.295. So that is perfect. And because this is so precise, I think putting this in the jaws on my lathe is going to be much easier too. We're not going to have a lot of wobbling happening. Whereas this one here is much more rough and it could wobble a little bit more and it might require some cleanup. If I'm in a pinch and I need a part right away, I think the lost foam method can work really well. But if I'm looking for parts that both look good and are more precise, the 3D print to create a plaster mold is a better option. I think there's still lots of room for improvement here too. I did not have a riser. The pouring basin might need to be a little bit bigger and a little bit of adjustment to the shape as well. And there needs to be some small vent holes drilled into the mold to allow some trapped gases to escape a bit more easily. The sprue and the basin should probably reach up a little bit higher as well. If you want to get into metal casting, I will have links below for anything that I've shown that I've purchased, and I'll also have links for my top 3D printer picks down there below as well. Thanks to my patrons for helping to support this channel and helping to make videos like this one possible. Thank you for watching. Take care, and I hope to see you on the next one.